Today we're going to talk about two things, metrics and experimental design. I want to start you off with metrics. Just a little review because I know you've had it before. Metrics is a very easy measurement system. It's easy because it's all in a power of 10, which means whenever you want to increase your ability to measure long distances, so you want to go from a small measurement to a large measurement, you just have to multiply it by 10. So it's pretty easy rather than maybe whenever we think of our English system that we use, if you want to go from a foot to a yard, you have to change the whole measurement system. So if you want to know how many feet are in a yard, you'd have to go and measure that. It would be 3 feet in a yard, where in the metric system, it would just be 10 centimeters in a decimeter or 100 centimeters in a meter. So it just makes it a lot easier because you can just move your decimal rather than having to do the math. And so I just wanted to review with you. First of all, I know that many of you learned this King Henry died by drinking chocolate milk. And I don't know why I started a long time ago making the ones that are smaller than the base measurement lowercase, but you don't have to do that. And then for our class, we're going to learn a new measurement. And it's it's two spaces beyond the milli. Okay, so if you don't know what these stand for, this is a kilo, this is hecta, deca. This one is the really important one. That stands for base. Okay, that is your base unit. All metrics, metric measurements, be they for mass or for volume or distance or whatever, temperature even, have a base unit, okay? And so that is going to be really important for you because we will use base units quite often. So you need to know where to find them. Otherwise, you might be very confused at what B is because it doesn't really make sense to have a B in the middle. There's no prefix that starts with B. So this is deci, and this is centa, and this is milli. Oh, that was supposed to be an I. Okay, and this is milli. And then these spaces are actually unnamed spaces. There's nothing there. Why do they need to be there? Because remember, everything is a multiple of 10. So 10 deca in base, 100 in centa in base, 1,000 milli. So then it would be 10,000, 100,000, and then you'd have another zero, so you'd have your million. And this is micro. Now you're like, well, that doesn't look like an M. Well, we already have an M right here, and we use these so frequently that actually it's quite nice that they didn't do the same prefix letter. This is actually a Greek letter mu. It's a Greek M, and it looks like a U. So when we type it on a typewriter, like you guys ever use typewriters, we type it on a computer keyboard, we just use the letter U. Okay, so you'll often see it in a typed format as just a U. The reason it's a U is because the Greek letter mu, the M in Greek, is actually quite U-shaped. And so it looks like a U to us. It has this tail in the beginning, so it's kind of like a pointy M. But otherwise, it looks a lot like a U. So we just type it as a U. So base units, we have meter, liter, and gram. Meter for length or distance, liter for volume, gram for mass. Okay, that's our base units. So the way you can tell if it's a base that you're dealing with is if it only has one letter, which would be M, L, or G. Okay, now L and G don't have a prefix. So if you see a L or a G, that's not difficult to remember its base. The one that confuses students is the meter, because meter is an M, and we have an M right here. And so students will get confused by that. Remember, if it's only one M, it's meter. If it's two M's, MM, that's millimeter, and that's when you'd start there. Let's do a practice problem, shall we? So that maybe you can remember how to do these. So when we convert from prefix to prefix, we typically will have, like, say, 476.79 cm is equal to how many m? All right, well, first of all, you have to know kind of what you have. So where are we on our little chart here? Now, some people make a little staircase chart. If you're comfortable with that, that's fine. This is just how I do it. If you want to do it like I do it, that's great. If you want to do it a different way, that's fine too. I'm not going to be grading how you get the answer. I just need you to be able to get the answer. So right now, we are at centa. So I take my marker and I put it on centa. This is where I am. I'm at centa house right here. Okay, where do I want to go? Well, I want to go to this M. Remember, it's only one M, so this is base. That's meter. All right, so I'm here at centa, and I want to go 2 doors down to base. So I'm going to take my decimal here at centa, and I'm going to go 2 doors down. And so you can make the little loopy things if you want. I just moved my pen. And so that's going to equal 4.7679 meters. Okay, I have also seen people do the little loopies up here. That really, really confuses me. If you're able to do that, that's just fine. But to me, I get confused on what side I'm supposed to stop and what side I'm supposed to start. And it's just easier for me to just say, here I am at centa, and I'm going to move 2 to the left. Okay, one more. All right, so let's say we have 0.67 liters. We want to know how many, that's an L, microliters we have. What's a microliter anyway? Well, microliter is a tiny drop. It's a millionth of a liter. And so we actually, I could hold it up here for you. We actually measure microliters at this cute little, this is a micro pipette. And so we can draw up just a teeny, teeny drop, and that's in it. And then if you dial it in, like this one says 130, and so that's 130 microliters, and you can change it and make it draw up whatever you want. Pretty fancy. But if we have this many liters, how many micro do we have? Well, we're at liter, so that's base. And you can pause your computer and do it first and make sure you can do it, okay? And then 1, 2, 3, 4, 5, 6. Don't forget to count the spaces. 6 to the right. 1, 2, 3, 4. I'm going to have to add 2 zeros. Okay, so that's how you convert your metric system. All right, that's it. It's not really super challenging. Make sure you do practice problems until you feel like you've got it mastered. Now we're going to shift gears to experimental design. Once you've learned to measure, it's really important that you know how to design an experiment so that it's fair and that it's valid every single time. Pretend that we are going to do an experiment to test the hypothesis that lemonade will make plants grow taller. In our experiment, this plant will be given lemonade to see if it makes it grow taller. This plant will just be given water. We'll talk about why in a minute. It's important that you set up your variables properly with experimental design. The dependent variable is the one that you're going to measure. I find it the easiest one to find. What are you going to measure? Whatever that is, that's your dependent variable. In here, it would be plant height. The independent variable is what you're actually testing. And so for these plants, this plant is going to be the one that is going to get water. And so it's not getting independent variable. And this plant is going to get lemonade. That's your independent variable. That's different than usual. But you have to have a control group. The reason we have the plant with water is because otherwise there's no way to compare your results. You won't know if you did any good or not if you don't have another plant growing in the exact same conditions, the only difference being your independent variable. Now let's switch experiments. So we are now going to test if a certain type of shoe makes you run faster. Let's say Adidas. So the question is, will Adidas make you run faster? What's your dependent variable? The speed of the running. What's your independent variable? The Adidas. What's your control group? Find it this way. Adidas make you run faster than what? Whatever that answer is your control group. We have covered a lot of material today. Much of it is review, but all of it is vitally important for your success in class this year. Every unit will have questions on it about experimental design, and the metric system will just pop up here and there. So please be certain that you review and that you refresh your knowledge, that you go over practice problems, and that you master these concepts so that you will be able to be successful as we continue through our class. Please let us know if you have any questions. See you soon. Have a great day.